Hello everyone, I'm the first speaker Tianting Lun to present our final term, pressure swing adsorption for oxygen, and the list is my teammates from Group 1. Oxygen is always indispensable for living, especially now we are under the threat of COVID-19. The requirement of oxygen for medical usage is increasing. Oxygen can be produced in small scale by pressure swing adsorption, abbreviated as PSA. We will divide this presentation in several parts. First, we will introduce the basic concept of adsorption and PSA, and then we will carry out two Aspen simulations to compare two different adsorbents. Finally, we will show our data and make a conclusion. Let's talk about the adsorption. Gas adsorption occurs when gas molecules interact with solid materials and retained by adsorbent. The absorption can happen because of variable reasons, such as charge difference, chemical reactions, and size of shape effects. Although there are many ways or different factors to affect the absorption, all absorption must involve at least two steps, the absorption step and desorption steps. The absorption step is aimed to selectively retain the absorbed species from the feed, in our cases, which is separating oxygen from the air. On the other hand, the desorption step is to release retained species from the adsorbent so that we can regain the capacity. As a result, the desorption step is also called the regeneration. However, there are only a limited number of material can accomplish the release in regeneration step. To carry out regeneration, we need to change the loading on adsorbent. We express the difference of loading as delta Q in moles adsorbate per kilogram adsorbent. The figure shows the isotherm on temperature T1. If we change the pressure at constant temperature T1 and just follow the isotherm down, as we know physically, there is less absorption at lower pressure. By this feature, we can achieve the purpose of desorption, and that is essentially the principle of pressure swing adsorption, PSA. Similarly, I showed two differences on the isotherm at two different temperatures, lower T1 and higher T2. As we raise the temperature from T1 to T2, there is less absorption at higher temperature. We call this method temperature swing adsorption or thermal swing absorption, TSA. Interestingly, the pressure of gas also varies with the temperature, so the combination of above two methods is called TSA-PSA adsorption. So we can get the same purpose by TSA or PSA. However, changing pressure of gas is faster than heating it up or cooling it. As a result, pressure swing adsorption plays an important role in chemical industry.